So essentially, we have four main topics that we're being tested on here. And these four topics are constant acceleration, which is technically like free fall. Free fall is one-dimensional projectile motion. Projectile motion, and then Newton's equations, which are inclined plane, blocks, sliding, attached to ropes, those type things, without friction, and then with friction. So basically what you have here is this is chapter 3, this is chapter 4, this is chapter 5, and this is chapter 6. But really, a lot of these things work together. If you're doing Newton's equations, you're going to end up using constant acceleration. You'll see that in this test. So it's kind of hard to say, oh, well, this is what we're covering. What I will tell you we're not going to cover is you're not going to get like a law of cosine problem. You're not going to get some adding vectors or adding velocities. None of that velocity addition stuff will be on there. There won't be drag. The drag won't be on there. But a lot of this stuff built up and became more complicated as we went. So really, if you know your projectile motion problems, and if you know constant acceleration, and you know what we've recently done, homework 5 and homework 6. The reason why I gave you the solution to those so soon is because I really want to make sure that you guys know, dot products and cross products won't be on the exam. They will be next time on the next one, but not on this one. This one's just these 4 types of problems. However, these 4 types of problems, there's a lot of different concepts. So I'm going to try to highlight the concepts as we go through and look at these solutions. And I'm going to tell you how you're going to be graded. The number one thing I try to do, if you looked at these questions, is you'll see that I give you the total points. And then each part is broken down to a point total. What this is essentially it's the rubric that I would grade you on. Where some professors might ask you this question and ask you for the end, what I do is I take a question and then I take it apart and I have you give me the steps, that you would normally have to do to get to some final answer. Show me those steps, and then I usually change the problem in some minor way that usually shows me you understand conceptually what's happening. And so if we think about that as we look at these 4 and the 4 on the other problems, hopefully you'll see that that's kind of what I expect you to be able to do. The good news is, knowing that, I'm going to show you kind of how I actually grade these, and we'll talk about it. So you'll know kind of what you missed. If you get your exam back and it says that you missed a few points, I will give you guys a breakdown in Excel with the last 4 of your student ID. I'll give you a point breakdown for each problem and each part of each problem. So you'll be able to go back and look and go, oh, I got a 0 on that part, why? And then you can ask me like what happened or what I graded. So you'll be able to see hopefully what you got wrong. The big problem is that I don't want to annotate 30 tests and try to resend them back to you. I find that works pretty well. Students can ask me like, how did I lose 5 points on that part? And I can go back and look at their test and tell them exactly why I counted off what I did. So anyway, it's not going to be a black box where you don't know. I will try to get them back. They'll probably be graded and back to you by hopefully Friday. I don't like ruining people's weekends that do bad on tests, so they definitely won't be back before Monday. But I'll let you know ASAP what you got. And I should have them done by Monday, but I don't want to promise Monday in case something weird happens. So anyway, let's get started. This is exam 1. Exam 1 started off with a problem that says, a vehicle of mass 6,000 kilograms traveling at 36 meters per second. When it begins to decelerate with a constant negative 11 meters per second squared acceleration or deceleration, whichever way you want to see it. The first thing I ask you on every problem, and this is actually, for those of you that are still have a lot of science courses ahead of you, this is one of the best tools you can learn to do. And that's the first thing you should always do, kind of sit down and go, what type of problem is this? What equations apply here? Whether you have them on a flashcard, whatever you have to know what equations and what concepts apply. And so the first thing I'm trying to teach you guys is, for every problem, I want you to write down 3 to 5 relevant concepts. It says 5, I'll take 3. If you don't know before you start the problem, you can go back at the end and put them in. They're basically free points. But I'm trying to get you all in the habit of kind of getting your tools out, knowing what you need to be thinking about and what you need to be looking for. So for this particular problem, we know it's constant acceleration because it says it right at the top. Question 1, constant acceleration. We have those equations that are x final minus x naught equals v naught t plus at squared over 2, blah, 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 blah. You can see them all there. So I just wrote the equations down. I would basically, if you have 3 good things there, I'll give you the full 5 points. It says 5, but I really only want to see that you kind of thought about it, or you went back and made sure and wrote down something there. Big, 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 big red flag here. Do not leave anything blank. I will try to give you points for things, but if you have nothing there, it's a 0. And the one way that people mostly fail my tests is they don't answer. The rest of this problem, it's going to look a lot like the quizzes, and that's why I give you the quizzes I do. First step is write down your variables, and it says it's worth 5 points. I've gone through this on the quizzes: x naught, x final, v naught, v final, a, t, and the mass. And then go back and look for what you know of those. We don't know x final. We're given the mass. We're given the initial velocity. We're given the acceleration is -11 meters per second squared. We can assume x naught is 0. We don't know v final. We don't know x final. We don't know t. I mean, I guess we can assume v final 0. I guess we do kind of know v final. So one thing that I know some of you have learned physics in other institutions, other schools, other universities, other colleges, high schools. I would prefer this type of variables. I can read it when you use u and when you use some of the other ones. Just make sure, though, that you're clearly labeling the initial position and the final position, the initial velocity, the final velocity, the acceleration, and the time. Basically, you're trying to fill out the variables that appear in the 4 constant acceleration equations and see which ones you know.
Professor?
Yes.
So for example, if we can assume v final is 0, do we have to explain why we assume that? Like it's decelerating at a constant rate and then...
I don't expect you to explain it.
Okay.
I could see that you decided that or you assumed that, and that might help me figure out what happened if you got it wrong.
I see.
But I will say this, for everyone here, I don't care if you're in chemistry, I don't care if you're in physics, I don't care if you're in engineering. Learn to write down what you're thinking. If you are thinking that, if you do put v final is equal to 0, say v final 0, vehicle stops, something, so that your instructor or your teacher or your professor or whoever's running that course can understand what's happening in your mind. Because sometimes it's a really, really simple assumption that you made that got it wrong. And assuming that assumption, you can do it all right from that point. And if they know why you assume that and it's kind of a valid assumption, great. If you make a mistake here, like let's say you assumed that v initial was 0, I want you all to know that what you write down here, if you then use it, as long as you do the math correctly, I'm not going to take points off because you did it wrong after. What I mean by that is your mistakes aren't going to compound through a problem unless they're major, you know. But if I can see that you would have gotten the right answer, but you made a bad math error somewhere, and so you had the wrong numbers going through, it won't hurt you that bad if you keep going with that. You're not going to like get to here and then because you got this wrong, the rest of the problem becomes a zero. I don't do that. However, the other thing I will say is if you didn't know, like we need to find the time here. And if you couldn't find it and you wrote, I can't figure out the time. I don't know how to do the time. Number one, try to explain what you think you should do if you don't know how to do it. Like, I think that I could find the time by using the change in velocity and the acceleration, but I'm not sure how to do that. I might give you a couple points there. If you really know, oh, I don't know how to find the time, do me a favor though. Write down for the rest of the problem, I'm going to assume that the time is 2 seconds or something. I find it funny that everyone that does that will pick a weird number. Pick one. One makes the rest of the math easier, and you know that the time is wrong, but you're saying, I'm going to assume it was 1 second and go from there. It just makes it easier on you. Remember, what I want is you to show me how to solve the problem. I don't put a lot of emphasis on the number. I'm going to talk about that here. So now that you've got your variables, that you basically read the problem and wrote down these variables, the first question that you're asked is, what is the force acting on the vehicle due to the acceleration? That's pretty simple, right? That's F is equal to ma, you have m, you have a, multiply. Make sure that you have a negative sign. Then I ask, how many seconds does it take the vehicle to stop? Give the equation that you're going to use. You are assuming here that v final is 0. I assumed it in my solution. And then I solved this equation, solved it for t. I wrote the equation that I'm going to use, this one, solved it for t. Then I put my numbers in. Then I put my final number. Okay. So now this is worth 10 points. And essentially what this is worth is basically each step here is probably worth a point. Meaning knowing F is equal to ma is a point. Actually, it's like 2 points. Getting this right, this negative 66 is another 2 points. Getting this part right is 2 points, knowing that B final was 0. Using this equation is 2 points. And then getting the time right is, let's say, 2 points. In general, that's how it's going to work. So your numerical answer is usually 20% of the points for that part. The big part of it is getting the right equation and getting the right variables in that equation. And then obviously, yeah, you need to be able to use your calculator correctly, but don't worry so much if you know that you're having an issue with your calculator. I'll also accept this. I will accept this number right here, negative 36 over negative 11. If you don't want to put in the time and you don't need it, don't even put it in your calculator. I'm 100% okay with that. I will accept negative 36 over 11 as 3.273 seconds. The number one time issue that people have on tests, people that end up running out of time, is they're messing with their calculators. The less you can mess with your calculator, the better. You should be able to multiply 6 times 11 times 1,000 and get 66,000, right? You shouldn't need your calculator if you don't really have it here. You'll need it for the next part, but here. As far as the concepts, this is just solving the constant acceleration equations for force, well, solving the force equation and then solving for time. This gets a little bit trickier. This is a little bit of a tricky question. It says, if the cliff was 57 meters away, would the vehicle stop? And so some of you may have a hard time changing gears. I sometimes have a problem changing gears in this way. But basically, I'm telling you that I want to know how far the vehicle has to go before it stops. And then I want you to compare it to this number. And that's checking to make sure that you understand that if you're asked that question, how to answer it, right? So basically, this is asking you for X final. You have your time. In general, whatever you found in the part before, you're going to use in the next part. So once you have X final, plugging time in here, you have everything that you need. And then once you have it, you need to compare it to that 57. In this problem, it takes 58.9 meters to stop, and the cliff is only 57 away. So it goes off the cliff.
Professor?
Yes.
Will we be marked off for sig figs during the test?
No, not at all. You may be marked off for units if you do something weird. I prefer units. I don't generally get too mad if you guys leave them off. I get more concerned when you put the wrong units. Like if you told me that it was, I don't know, 58.9 newtons or something, I don't know. But no, you won't be marked off for sig figs, and you probably won't be marked off for units. But please learn to always write your units if you can. I get lazy too, and I drop them sometimes, especially when I'm focused. But yeah, no.
I see.
Sig figs aren't that important. I generally go with the smallest number that I had, but here I actually went one more. Well, I don't know. I don't know what the sig figs are on this. I mean, technically it's like one. Yeah, whatever makes sense. Just please don't give me 14 numbers, like 11.36891888.
Sounds good.
Yeah, that doesn't make sense to me.
And then do we need to put our answers in complete sentences?
Nope. Not
okay.
at all. You don't have to use English on this test at all if you don't want.
All right, thank you.
If I can read it, I'm cool with it. If I do ask you to explain something, like I explained here, all I wrote was no. I'm just asking, would it be able to stop? Nope. Some people might want to write, since X final is 58.9 meters and that's greater than 57 meters, the car can't stop. And I think that's great. But if you just want to write, it can't stop, I'm okay with that too. Yeah, so. But I will say that you could get counted off if you don't put anything. If you just wrote 58.9 and assume that I would know, but I'll generally tell you that on the day of the test. I'll go through and say, hey, when you do this, I want an answer. If it says justify your answer, I want you to do something to show me the answer, whether that's a sentence or a inequality sign or whatever it is. All right, so this says, if the car cannot stop in time, what would the acceleration need to be to stop in time? And so that's a little bit weird. That's actually a bit of a red herring, because it says use X final is 57. You don't really need to use time to figure out what the acceleration needs to be. But in that case, you assume that you don't know A. The initial is still 36 or whatever it was. And X final would be 57. So again, there, it's a pretty simple problem unless you get confused on your variables. So you really need to know what your variables are. It really helps to have a drawing or something. But here's the big thing. Sorry, I need to see. Yeah, you want me to maximize this page, Ali? I'm sorry. I was trying to make sure I had somewhere I could write, but this is actually in the practice solutions if you want to open it too, if it helps you out. Here in this problem, we assumed that we didn't know the acceleration and we had to find it. And I usually rewrite my variables. You don't necessarily need to, but I find it helps me to always do things the same way every time. And then the last part of this is a little bit weird. I'm asking for a ratio, which means I want to know the ratio of this acceleration to the original acceleration. And I want you to use that to determine time. Whenever I ask you that, in general, what I'm asking you to do is to divide two equations. So you have v final minus v initial is equal to AT for the first part, and v final minus v initial is equal to AT for the second part. This becomes T1, T1, V naught 1, V naught 1, blah, 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 blah. But these are the same. So we get that side is 1, and this is A1, T1, A2, T2, and you can use that to solve for T2 as a ratio. Now, what if you didn't understand how to do that at all, and you just solved for T2 using this A and V initial and V final? I would be okay with that. In fact, that's what I did here, which is fine. It says or. But really, I want to make sure that you all understand that it's a really nice, helpful trick to be able to divide equations. Sometimes it's super useful. In this case, it lets us find T2 without having to solve it, because we can see this. Well, I guess we still solve it, but we can see this ratio and multiply it. Anyway, that's all good. I need to let my dog out really fast. Hold on. Bye. All right, so I won't be as long on the rest of these questions, I hope.
Professor?
Yes.
Quick question. Why are we able to have the two equations for the V final and V naught cancel out into one? Because isn't the V final for one of them 38 point something and the other one 37?
No, they both are 0. This is the acceleration times the time.
Oh, I see. Yeah.
So this would be 0 minus 36 over 0 minus 36.
I see.
I really should have written little subscripts 1 and 1, 2 and 2, but yeah, they are exactly the same, which makes it really helpful.
I see. Thank you.
Yeah, it's not really needed. This is actually probably faster than doing a ratio, but I want to make sure that you all know that trick. It's really useful. Use it in chemistry, use it in engineering, use it wherever. So just a quick review. I want you to always list your variables, list 3 to 5 real good concepts or equations. Make sure that you always list the equation symbolically before you start putting numbers in or before you start solving it. Tell me what equation you're using. I want to see that. I need to see that. I need to know how you got to your answer. And then if I ask you to justify your answer, I just want like a sentence or a quick comment telling me what's going on. And if I ask you to do something weird, I'm going to be here during the whole test. My mic will be off, but you can turn your mic on or you can send me in the chat any questions you have. So if you don't understand what I mean, please ask me. Feel free to ask me. I'm not one of these teachers that will tell you, I'm not going to tell you that. I'll at least give you a hint. If not outright say, yeah, what I want is I want you to take the equation V final minus V initial is AT and divide it by the other equation V final minus V initial is AT. Mostly what I'm looking for is the point of this whole course is that you guys understand, and I'm sorry, I keep saying guys, I don't mean any disrespect to the female students. It's just a term I use. I'll try to stop using. I want you students to be able to solve physics problems involving motion by the end of this course. So what's most important is that I see that you understand a logical, consistent approach to your solutions. So if you're bad at math, it's okay. Just make sure that you can get the equations. If the numbers get weird in your head, it's all right. You're not the only one. But show me logically how to solve the problem. That's what I'm looking for. So projectile motion. in our homework, you had a whole bunch of different projectile motion problems that had various different initial conditions. Velocity was initially horizontal or down at an angle or whatever. Heights were different. So you can expect I'm going to try to find something interesting to do with projectile motion. They're all solved the same way. So in this problem, what you can see here is we're launching two projectiles and having them collide at their maximum height. So they'll have the same maximum height, but they're going to have different angles and different initial velocities and different distances to that point of max height. So basically we have two projectile motion problems that have the same maximum height. And so what we're going to do in this problem is find out some information from it. It's something that when I gave this test, the students hadn't seen a problem like this. But it's not hard. It's actually not much more difficult than a normal problem. So 5 concepts here. A is equal to minus g. In the y hat direction, it really should say. V naught of y is v sine. V naught of x is v cos. V final of y is 0 at max height. Any of these that you want to write down. Give me 3 to 5. Okay. The first thing that you do in projectile motion is list your variables. Now you need to assume, or you need to decide what part of the motion you're talking about. The variables are different when we're going to max height versus, full. So this set is the equations for max height for the left and the right side. And you can see that I put y final was h for both of them, y initial was 0 for both of them. V initial on the right was v2 sine theta 2, v1 sine theta 1 for the left, blah, blah, blah. I know you guys can see all of this. And so the first thing we need to figure out is what is this angle, right? It's actually the first thing I ask is what is that initial angle? Now, in order to find it, it's actually kind of hard to find. You could set these equations equal to h and set them, you could basically solve an equation equal to h for both of these and set them equal to each other to get rid of the amount of unknowns because you don't know h. Or you could divide the two, which is what I did. This on top is left, on bottom is right, or yeah. So when you do that, you know that this whole side is equal to 1. They have the same acceleration. They have the same time. I tell you that up here, that they hit at the same time. And in fact, you're not given that time, but you know that they have to hit at the same time. So you can do that thing that we just talked about, dividing the two equations, and you end up with this. You're trying to solve this for theta 2. So sine of theta 2 is v1 over v2, sine of theta 1. And when you do that, taking the arc sine, you get 34.3 degrees. This is actually really hard. So if you think this is hard, yeah, this is actually a pretty hard question. Almost too hard of a question. But that one's a difficult question. I do admit that. The rest of this problem is pretty easy. Finding the max height, we've done that a ton of times. You could find it for the right or the left side. And then how many seconds to max height, we've done that a ton of times. So I don't think that part's particularly hard. Again, 10 points, 5 points for each of these, 2 points for the equation, 2 points for getting the algebra right, and 1 point for getting the answer out of your calculator correctly. So you can see if you got an 8 out of 10, you probably messed up your algebra somewhere. But I guess that would move more like a 7, because if you messed up your algebra, you get your number wrong, but whatever. The last part of this one is finding the total distance. And again, this is one of those things where you need to find how far x is at the time when y is at h, and how far x2 is at the time when y is at h. And then I want to know the distance that they were away from each other when they launched, which means you have to find those two and add them together. That's not particularly hard. It's just doing it twice and then adding them together. So essentially, if you wrote down x final 1 is v naught 1 cos theta 1 t, and x final 2 is v naught 2 cos theta 2 t, this is about 5 to 6 points right here, especially if you recognize that t is the same for both of them. That's most of the problem is right here. Everything else is just putting numbers in, and then a couple points for knowing that you needed to add them. But here's the thing. I probably won't make you do this on your exam, but it's the type of thing that you could do to make projectile motion problems are actually not super hard. So you got to find creative ways to make them interesting or a little bit challenging. And that's what I did on this one. So anyway, then I said that the first problem would be free fall or constant acceleration. It was the car sliding towards the cliff. Second one will be projectile motion. Third one will be Newton's equations without friction. And fourth will be with friction. These are what I call Newton's equations. They're blocks on strings or ropes and over pulleys. So you're given in this problem the angle, you're given mass 1 and 2 and mass 3. And I gave you the direction of motion, okay? That's always an issue with these. So if I hadn't given you this direction, would you know the direction it's going to go? Maybe. This mass is 50 kilograms, and you could have chose this direction. Why do we need the direction? Because A in this direction, and A in this direction, and A in this direction will all be the same A. Those ropes are always, for our problems, massless, stretchless, frictionless. That means that A along the direction of the rope should always be the same A, and B should always be the same B. So in this direction, 2 and 3 and 1 all have that same velocity, that same acceleration at any time. If you didn't know though, and you assumed this was true, and you got a negative sign for your acceleration, that would tell you that this thing should be going the other way, that you chose wrong. And that's okay. It's fine. Basically, those arrows tell you the positive acceleration direction. And that'll happen sometimes. The big thing is to be consistent. If this arrow is going up, this arrow shouldn't be going backwards. You shouldn't be trying to say that 2 is going down the incline while 1 is going up, right? That makes no sense. But in general, I'll give it to you because it just makes everything easy. Concepts, I listed everything I could think of. Free body diagram. Mass is the sum of the forces stretch, massless ropes. The constant acceleration equations. On the incline, the weight in the x is mg sine, weight in the y is mg cos. We'll talk about that in a minute. Weight is mg, and then the different forces we can have. Weight, tension, normal force, friction, or weird, not friction, weird other forces. So the first thing we do on these types of problems, the first thing I'm always going to ask you for is a free body diagram. And a free body diagram, what you do is you draw it with these things. Free body diagram has to have 3 things. So it has to have the forces, it has to have the x direction, well, the x positive direction, and it has to have the acceleration, which is usually in the same direction. But the forces are only on each body. Each one, mass 1, 2, 3, gets their own free body diagram. So looking at mass 1, you draw a circle, and then what are the forces? And remember I said weird forces, normal, tension, and weight. Everything has a weight, and weight is mg. And mg always points towards the ground. So this is m1g. This is the weight of 1. And it points downward. it has to have a tension because it's got a rope attached to it. If it has a rope attached to it, it has a tension. If there's more than one mass, you need to somehow specify, is this the tension between 1 and 2 or 2 and 3? I do that by writing tension on 1 due to 2, but you could write TA and TA. So you could basically write that this was TA. Now, when they're up and down like this, I don't really care about the positive X direction. Really what I care about is that you write A or V. I want some kind of acceleration, showing the direction of motion. And we'll get into why that is in a second. For number 2, well, let's do 3 really fast. 3 has a tension up, the tension on 3 due to 2, and it has a weight down just like this one does, M3G, and it has an acceleration down now. But 2 is always the problem. We do this trick that's in that first problem of your homework on chapter 5, where we turn this incline on its side so that X is along the incline, and we set this thing here. Now, it has a normal force, everything that goes up or down does. It has a weight, if you think about it, that goes straight down like this, right? Which means it has weight in the X and weight in the Y. It has components of this weight vector, but we need to find what this angle is. Well, you know that this is a 90-degree triangle, and that means that this is phi, and this is also a 90 degree, so this is theta again. So weight in Y points down. You need to turn your head kind of, and you'll see that weight in the Y is mg cos theta. It's along this part of this theta. Weight in the X is along this part of this triangle with this weight, so it's mg sine. If that's been bugging you, that's what it is. And then we have the 2 tensions, so those are easy to draw. Whether you call them TA and TB, whatever. This is tension on 2 due to 1, and this is tension on 2 due to 3, but these tensions are equal and opposite third law pairs. There is a normal force. There is a normal on 2. M2G cos, and there is M2G sine. Now Y, oh, and then I make sure that I draw my X and Y. Which way is X? And I draw the acceleration or velocity vector. I want all of those things on your free body diagram, and you can see them here, that I've done that. Everything that's on here is what I want. Essentially, everything on here is worth a point. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, and I probably gave a couple points to make sure that you knew how to break this up. But usually I start taking points away if you're missing vectors. And for every vector you're missing and every acceleration you're missing, I take away a point. So make sure they're there. But why do we draw a free body diagram? For those of you that don't understand why we do this, you can immediately write the equation of motion, and we'll just do it for one of them. But looking at this, we know that M1, A1 is equal to, since we chose up to be our positive, tension is positive, minus M1G. Had we chose it A to be down, these signs would be flipped. It would be M1G minus T, okay? Essentially, this is a visual representation that you can turn into an equation in the X and in the Y. The acceleration in the Y is always 0 because it can't leave the surface. This guy can't leave the surface, okay? These blocks we're assuming don't swing back and forth. So they have no motion. And when we say the X direction, we mean the direction of the rope. They have no direction or no motion other than up in the X and down in the X and up the incline in the X, okay? Now, give Newton's equations symbolically for each mass. What I'm saying is give me these equations for each one and give them for Y and X. So for number 1, I'm going to shrink this just a little bit for a second. No, I'm not. Sorry. So what you write is M1A1 is equal to T minus M1G. And M3A3 is equal to M3G minus T23 here and here. Then you do the X and the Y. In the Y, we know that this is M2AY is equal to N2 minus M2G cos, which is exactly what I wrote here. You can put the 0 in if you want right away. You know that the Y is 0 because it can't leave the surface. In the X, this is why I have you draw a positive vector or a positive acceleration vector. I chose to the right to be positive. So M2 A2X is T23 minus M2G sine theta minus T1 T2 or T1 2. And so that's what I have here. Now we know these are equal, and we know that these are equal. So essentially, once we have these equations, write them so that rewrite them so that they're in the form where the tension, and then that way you can plug these tensions right into this equation. Now, usually I ask you, at least on the first test, a couple of standard questions, and this is one of them. How do we know that the acceleration of each mass is equal? Well, it's equal because massless, stretchless ropes. So A1X, A2X, and A3X all have to be the same acceleration. Now, behind the curtain, what I'm doing is I'm reminding you of that fact, that this A and this A and this A are all the same A. So when you plug it in, they're all the same A. And then I ask you for the net acceleration of the system. I want you to solve these three equations to give me A. How you do that is you plug this in for T12 and you plug this in for T23, which is what I've done here. Collect your terms. Now, a really quick hint, put a little star on a Post-it note. When you do this, you should always get an equation that looks like F equals ma on one side with all the forces on the other. That means that all these masses should be positive. If you end up with a negative mass over here, you've done something wrong with your sign. You've got an inconsistency in your arrow, or you've got an inconsistency in a vector, you've got a vector backwards, whatever you have. But at that point, you're just basically solving this equation for A after you plug in the two tensions. Now, how do I know that the tensions are the same? Which one of Newton's laws? Newton's third law tells me this tension and this tension have to be the same. The force acting on 1 due to 2 has an equal and opposite force acting on 2 due to 1. And that's what these tensions are. All right. So once you found the net acceleration, once you've given me a number for that, what can we do with that A? Well, what I asked in this problem is I asked, well, wait, what if we reversed it? What is the ratio to the acceleration if it was reversed? Now, when I do that, there's usually a fast way to do it and a hard way to do it. The hard way would be to rewrite all your free body diagrams. But when you do that, what you're going to see is that the only thing that happens is you flip this sign and this sign and this sign, right? And when you do that, you end up getting this reverse equation. M2G sine theta has a plus on it, and these two end up actually flipping. Why did they not flip when A is reversed? Oh, it doesn't matter. Why wouldn't that be down? I think that should actually have a negative sign on it. Am I wrong? No, I guess I'm right. This would be, anyway, I'll double check it sometime later. basically find this equation again and divide it by the reverse equation. And then solve it for the ratio. That's kind of hard, but not really. Basically, I'm just asking you to reverse it. And it is bugging me a little because I think this should have a negative, but I don't want to go back through the math. All right. Anyway, so yeah, on these problems, notice the point values, 15 points and 10 points. 25 out of the 55 points is just in doing the right free body diagram and doing the equations from it. And then there's usually a question like this. So if you knew this and you knew how to do these, you would already have 35 of the 55 points. Doing the algebra is a big pain, and this is a little bit weird. And as I said, if you already did this and you got something different, it's bugging me because I think this should be M3A is equal to T23 minus M3G, which should be a plus. So they should both be negative here. Oh yeah, and that's what yeah, there's a sign error right there. Anyway, doesn't matter. All right, well, sorry about that. So finally, the last question that I'm going to give you is going to be this type of Newton's equations with friction. In this problem, we have two masses on inclined plane and one on a flat surface. You're given their masses and you're told that the coefficient of friction is the same for both of them, but you don't know what it is. And you're also told constant velocity. Now, whenever you're told constant velocity, I try to remember to bold it for you guys. But that means that A is equal to 0 in this problem. We do this problem the exact same way with one change. We have to add friction. And friction is always going to be kinetic for us in these problems. And it always opposes whichever way you're traveling. So this becomes really important here when we're writing our free body diagrams, that we get the friction going in the opposite direction. Friction has a form negative mu n, but forget about that negative sign. That negative sign is telling you that it always opposes the motion. It's in the opposite direction to the motion. And remember that constant velocity is A is equal to 0. So we're told that the angle is 66. When I write these, mg sine, mg cos, normal, tension, and friction, which is what I have here. Normal, mg, tension, friction. Make sure that you label these with 2s and these with 1s. A in this horizontal is the same because they're attached by stretchless, frictionless ropes. Once we have these, all you do is write these down. So this is MAX because AX is going that way. M1 AX is M1G sine theta. It's in the positive direction. Minus T minus force of friction. When I put this FF1 in, FF1 uses a magnitude, mu n1, which is what you use the y side for. Remember that the y acceleration is 0 because it can't leave the surface. And basically from there, you've got everything for this. When you rewrite this equation, this is mu n1, T is m2a plus force of friction 2, where force of friction 2 is mu n2, and where n2 is m2g because the normal is opposite the weight with no sine or cosine on it. All right, anyway. Part D, what is the net acceleration of each mass? How do you know this? Which of Newton's laws is relevant? This says 10 points. That's because I didn't want to give it away, that it was a very simple problem. Constant acceleration is 0, which means all the masses have no acceleration. That's either Newton's first or second law. You could either say it's the first law, object at rest stays at, or tends to stay at rest, object in motion stays in motion, or it's the second law, which is F equals ma. You could use either one, and I would accept either one. Now, once you have these, I want you to do something with them. And what I want you to do here is tell me what that mu is. So what you would have to do is plug in m2g for n2, plug in for ff2, mu n2, same here. Solve this for t and plug it in over here, and you get this horrible equation. But you know that the MAs are all 0. So if t is minus mu m2g is equal to 0, then t is equal to mu m2g, plug that in there. This is mu m1g cos theta, but this a is also 0, and so you can solve this. It's 0 because of the constant velocity. I gave you the masses, I gave you the angle. You can use that to solve for mu, and you find that it's a little bit greater than 1. It's okay that it's a little greater than 1. The last thing that I asked in this exam is, if there were no friction, what would the acceleration be? Now again, when you have to go back through and do something like this, there's usually a fast way to do it. The fast way to do it here would be just to set this term equal to 0 and this term equal to 0. And you know that t is m2a, plug that in here, move it over, and you get that a is m1g sine theta divided by m1 plus m2. And that's all done here. So usually at the end, if they change something in the problem, usually you can just go back and modify your equations. And that's it. I mean, I know it's a lot. I know it's a lot of little moving parts, but essentially, if you go back through and kind of write down what concept we're using, that's what I'm testing you on. It's the concepts, right? So here it's figuring out variables, but here it's F equals ma. And here it's just constant acceleration equations. Here it's finding the time to max height. It's finding the x distance to max height, things like that. I'm sure you understand. I guarantee this part will be on the or on the test exam somewhere. 3D, word for word, this will appear somewhere. And I also guarantee that something very similar to this will appear on the exam, where you'll be asked what the acceleration is, and you'll have been told it's constant velocity. These are the one thing that I think I'm kind of a jerk about, because asking this question, if you didn't realize it was 0 because of constant velocity, you could waste a lot of time doing the algebra. So always make sure and go back and reread the question and make sure that it's not saying constant velocity, because constant velocity means acceleration is 0. And that makes everything that would look normally ugly, like plugging all this stuff in looks ugly. If you can cancel the A's, it becomes really fast and easy. Okay, any questions on that? I'm going to go through the second exam much faster than I went through this one. Mostly because I don't want to, a lot of it I've already covered right now, but this one. So this one is actually kind of fun. I'm just going to talk about these problems a little bit. So this problem, imagine that it's not falling. This problem is about a mass that's turning with uniform circular motion. And you know, for uniform circular motion, all we've learned so far is that it has a radial acceleration that is equal to v squared over r. R has to be constant, v has to be constant, okay? And it has a period it goes around once, 2 pi r over bt. We're told in this problem that this thing's spinning around and then it's allowed to drop. And when it drops, we'll talk about this in a minute, but when it drops, it's going to continue to spin around and around and around. We're going to assume that nothing changes in this horizontal motion. And even though it's spinning, its initial vertical motion is 0. So it's at a height of 33 meters, stress lift, mass lift, blah, blah. It's traveling in a uniform circular motion horizontally with this radius, unknown radial acceleration. It has no Vy. Vy initially is 0. And it falls from free fall. So this problem is actually a really easy free fall problem of dropping something. So first thing, give me those 5 equations, or 3 to 5. List your variables for free fall. Y initial is 33, Y final is 0. You could also put that Y final is negative 33 and Y initial is 0. I don't care. You need to know that it's dropping from rest, the acceleration. And it says, how long does it take to hit the ground? Well, in free fall, we can find that pretty fast from the free fall equations like this one. If we know that Y final is 0, this is 33, V naught of Y is 0. This is actually a really fast equation to solve for t squared. Take the square root. Make sure you take the positive time. Once you have that, you can find V final in the Y direction. In the X or horizontal direction, though, it's still going to be moving in uniform circular motion. What is that velocity? Well, we can find that because if it makes only one complete rotation before it hits the ground. No, we may have some uniform circular motion, but really it's just these 2 equations right here that govern it. This problem is a little unique because it's moving in uniform circular motion while falling, and you just treat the 2 motions as totally different, except for the time. The time that it takes to fall is also the time that it takes to make one complete circuit. The time to take of one complete circuit is the period. So from that period, if you knew it and you knew the radius, you could find its velocity horizontal while we're given the radius. So we're able to find the horizontal velocity. And then from that horizontal velocity, the radial acceleration is v squared over r. And then finally, if I want to know what the magnitude of its velocity is at any time, remember that this thing is essentially, if I try to draw, it's got v tangential from the circular motion and v in the y. And so this forms a vector that looks something like this, and you can find this angle from tangent of this angle is Vy over Vt, except that you know that that's going to be a negative angle. You can find its magnitude by squaring them. All that good stuff that we've done a bunch. This problem is a bit weird, so make sure you know it. But this problem is the key to everything we do, in that you're taking equations for the x direction motion and equations for the y direction motion, and we're combining them into one. Okay. What you won't have is you won't have uniform circular motion with the forces, but we may have a little bit of uniform circular motion. Now, this problem, second problem, projectile motion, is the same as normal. There's a bird traveling overhead, and a hunter aims his arrow and fires it. And when he fires it, it's at some angle. It has an initial v of 30 meters per second. So we don't know the angle. We do know, though, that she is firing from an initial height of 2 meters. And the arrow has the same x velocity as the bird, which is 50 meters, 5 meters per second here. So this is a case of you have to write your variables. X initial, of course, is 0. We always set it that way. Y initial is 2, though. X final, I don't know. Y final is max height. I don't know that either. V initial of X is 5 because we're told that assume the bird is initially directly above and the arrow has the same horizontal velocity as the bird. You have to assume the bird's directly overhead so that if they had the same horizontal velocity, it would actually hit the bird. And then V final of X is still 5 meters per second. A of X is 0. Time, we don't know. V initial of Y is V naught sine theta, and we don't know theta. It turns out, or do we know theta? No, the launch angle is initially unknown. We're going to find that first. We do know the magnitude V naught is 30 meters per second. So what's the initial angle? Well, if you're told that V naught of X is 5, you know that's V naught cos theta. And you know that V naught cos theta, you know that V naught is 30. So you can find the angle from this. Taking the arc cosine, and you get that it's about 80.5 degrees, 80.4 degrees. From there, once you have that angle, it's super easy to find the maximum height that the arrow reaches. If I tried to put this in, I wouldn't have time. If I use this equation, I can, assuming that at maximum height, the final velocity of the arrow is 0. I can find that the arrow can only reach 46.6 meters up. Now, don't forget that your Y initial is 2, not 0 in this case. And you find that the maximum height of the arrow isn't enough to hit the bird. Things you might get counted off for here is basically getting this equation wrong, or getting this equation wrong, or forgetting that Y naught. So don't forget that Y naught. Since you found that it doesn't hit the bird, how many seconds does the arrow take to reach the ground? Again, if initial and final were the same height, that's really easy. Because this equation, if Y final is equal to Y initial, and there should be a T right here. Forgot the T right there. This equation is really easy to solve for T, but when you have an initial height, you end up with a quadratic. So you end up with this equation, move the Y final minus Y initial over, and you get that A is the term on the squared, B is the term on the single power, and C is the constant term. Plug those into your quadratic. Remember that it will give you 2 different times. Choose the positive time, not the negative time, okay? It'll give you 2 different times because this is plus or minus. In this case, I can see that if I chose the minus, I would get basically 60 seconds over 10 seconds, which is like 6 seconds. And if I chose the plus, I would get negative 3 seconds. So just make sure that you choose the positive time. What is the maximum distance away? Again, you know V of xt, x final, we found t, that part's simple. All right, so this one isn't much different than the first one on exam 1, where we have 3 different, except 2 of them are now on inclines. Remember that this is mg sine, this is mg sine, the weight in the x direction. This you should be able to do pretty fast. The tensions, you have to make sure that the tensions are all on there. Tension between 1 and 2, tension between 1 and 2. Tension between 2 and 3, tension between 2 and 3. These are third law pairs, equal and opposite. There better be an opposite tension here to the tension here. There better be an opposite tension here to the tension here. And they're the same force, right? So once you do these free body diagrams, write your equations. Remember that I'm probably going to give you the direction of the motion So then you need to make sure that you include it on your free body diagrams. It isn't here, but it should look exactly like these. A should go that way. And once you do that, you just go, okay, M1AX is in that direction. So it's T12 minus M1G sine. M1AY is up, so it's equal to N1 minus M1G cos theta, but you know the Y1, it can't leave, so it's 0. Same with 3, there's no X equation. AX is equal to A is equal to AX. So this acceleration is equal to this acceleration is equal to that acceleration. Why? They're connected by stretchless ropes. That's our next thing. Since these are all connected by massless, stretchless ropes, you know A1X, A2Y, and A3X, that should be an X, are all equal to what we'll just call A. And that's because, we know this because they are massless, stretchless ropes. Otherwise, we couldn't do the problem the way we're doing it. Then I asked, what is the net acceleration of each mass? Well, for now, you would go back and look and make sure it doesn't say constant velocity anywhere in the problem. And then just substitute for, solve this for T12. So you get T12 is equal to M1 A1X plus M1G sine, and plug it in there. Solve this equation for T23 and plug it in there. And then do some algebra and solve it for A. Now, here's the thing. You have A. Forces in our class are considered constant. So we can use constant acceleration equations. It says if the system starts from rest, how many seconds does it take for mass 2 to rise 3 meters? All you do is go back and treat this like a constant acceleration equation. Y initial would be 0, Y final would be 3, V initial would be 0 because you're told it starts from rest. A is the A that you found previously. It's not G, it's not minus G, it's just A. Once you have these things, you can plug them into this equation to find T. You can plug them into this equation once you have T to find V final. That part's pretty simple. This one is friction here, but it's not an inclined plane. It's a flat plane. So this one should be pretty fast and easy to do. Exactly what we've done before. The tensions associated with each mass are equal. So the tension here and here are equal and opposite. Which of Newton's laws tells us this? And what is the net acceleration on each mass? Their tensions are equal and opposite because they're a third law pair. And the net acceleration on each mass is 0 because they're moving with constant velocity. And we were told that right here. Okay. All right. And then what is the kinetic or the coefficient of kinetic friction? So we have this, and we can solve this equation for T. T is M2G minus M2A. Plug that in here. The force of friction is mu N. N is mg, M1G I should say. So you have everything you need to plug stuff in and then just solve the equation for mu. But here, you know that the acceleration was 0 because of constant friction. So that becomes 0. And you know that the tension was equal to mu M1G, and the tension you already found was M2G, and so you get this, and you find that it's a half for this particular problem. Just algebra. The final question is, what if we got rid of mass 1, the one on the friction surface, and gave it, or put one that was frictionless? And I want to know what the acceleration would be if that were the case. So I want you to solve this if there were no friction. And here, don't use constant velocity. You go and look here. If there were no friction, this doesn't exist. And that means M1A1X is equal to T, and T is M2G minus M2A. So you get basically M2G over M1 plus M2, which is what is here. So I know I went through this test pretty fast, but the main point was make sure you can draw free body diagrams. Make sure you can write Newton's equations based on your free body diagram. Okay, make sure you always write something. And then these ones that I actually wrote sentences, make sure you understand them. But you can see that this problem consisted of, what is that, 6 parts? Part 1 was just writing some concepts. Part 2 is free body diagram. Part 3 was just writing down the equations from the free body diagram. None of that is actually like calculations. It's all the physics that we need to know, which is what we're in. We're in a physics class. So yeah, physics is all math, but it's not always all math. D, make sure you know this. So we didn't actually start doing any calculations until part E, which was only 5 points of the 45. And then we had to change the system a little bit, right? So yeah, as far as how I would study this stuff is I would really look at what I was being asked and how I solved it, not mathematically, but what equations I used, what I was given, kind of how I did this, if you have time. If you don't have a lot of time and you have put off your studying, the number one thing I would do is homework 4, 5, and 6. Go back through those problems and try to do them. Get as far as you can, and then move on to the next one. And just keep trying to set them up and get to the point where you could plug them into a calculator and then move on, right? We only have 2 days. Because what's most important is how you solve them, not getting the answers. If you're studying and you find yourself spending 15 minutes trying to figure out why you got 8 meters per second when the answer should be 12, you're probably wasting a lot of your time and energy. So don't do that. But try and set those problems from 4, 5, and 6 up. See if you think you understand how to approach those problems. Those problems are harder than ours, but in general, there's a Atwood machine on our homework. There's a table with 3 masses that are hanging. You should have enough examples to work through. Work through them on your own without looking at the solution and see how far you can get, okay? But any questions for me, any specific homework you might want to go over? If not, I'll let you guys run and you can get on to studying or working on other tests or homework you have. I'm all good. If Alexis is still here, and Tristan, thank you both for giving your thing. If you need to email something to people, let me know. I think you guys need to, if you want to get, if you're interested in Alexis and Tristan's thing, I think it's tomorrow, right? That it might be going on. So contact them right away if you can.
Is it okay if we post a discussion to the class?
Absolutely. Yeah, that's fine. And then there's a Discord somewhere. You could probably
I'll send it there as well.
Yeah.
Thank you so much, Professor Boyd. And thank you for the review.
Yeah, no problem. So I hope everything goes well. One last thing for everybody who's here. If I don't see you pop into the Zoom on Thursday, I might panic a little. I'll probably send you an email asking where you are. So if something's going on, email me right away and let me know if something's happening that you can't get into the Zoom or that you're having technical difficulties or whatever, okay? But other than that, I hope you guys all have a great couple days of studying, and I hope the test doesn't stress you too much. It'll probably be easier than you think it will be. Okay, so I'll see you all later. Good luck.
Thank you so much, Professor. Have a wonderful day.
You guys
Thank you
too.
so much. Bye. Have a good
Bye.
one. Thank you.
You're welcome. Gabriel, it is on Thursday, 2 to 4:50. No, it'll be four questions. It won't be 2 parts. It'll look like a practice exam. Did that answer your question, Gabriel?
Yeah, so it's gonna be how you showed us 2 of the solutions, like on the other exam thing and then this one.
No. What it's going to be is it'll look like one of these exams. So it'll have like 4 questions. One will be like this. One will be a constant or free fall or constant acceleration. One will be projectile motion. One will be without friction, and one will be with friction. So
Oh, these are
if you can do the 2 practice exams, or at least most of what's going on the 2 practice exams, you'll be fine on the test.
oh, so they're the same, just different like questions. Both of these practice exams. Okay. All right, makes sense. Thank you. Bye, take care.
Bye, everybody. Bye, Tiffany. Bye, Javon.